Hey guys, so I'm going to be going over some of the vocabulary that we've gone over for 1.1. And the first one that I'm going to be starting off with is a population. So when you think of population, you think like a group of people, right? But in terms of stats, it's a group of all people that you're interested in. And if it has the word all in it, it's most likely going to be referring to the population. So let's say that I wanted to do a survey to find out like how many textbooks on average all West Hill students had. So I'm just gonna make this example. So if I want to find out how many the average number of textbooks that all West Hill students have, then my population would be all West Hill students. Just note that how the definition and how my example both have the term all in it. So yeah, that's a really big hint that it's going to be referring to the population. And so I want to find out how many the average number of textbooks that all West Hill students have, but it's going to be super hard to be able to survey all of them. Like, let's say they're not available. Let's say that I'm just not able to reach all of them. So instead of having to survey all of my population, I'm just going to be taking a sample. And then a sample is a subset of your population. So this just means that it's like they're the same as your population, it's just a way smaller group. So they have the same characteristics. It's just a lot more available for you to get information from them. So let's say that I want to make my sample for my survey be like 50 West Hill students. So notice how they're still West Hill students, like how I wanted my population to be, except that it's just a lot more smaller of a group of West Hill students. What I'm going to do now is I'm going to be getting data from my sample, and that's where your another term comes in, and that is a statistic. So a statistic is a characteristic or a number that belongs to your sample. So the characteristic that my survey was trying to figure out is the average number of textbooks that all West Hill students have. So average, I'm looking for the average number of textbooks. So that right there is going to be my statistic. So the average but statistic is it's only data that's from your sample. And my sample only had 50 people. So I better make sure that those 50 people are expressed in the statistic. So notice how in my example, I made sure that I had a characteristic, which is the average number of textbooks, but I also made sure that I had my sample in there. So yeah, if it's a statistic, it's going to include both a characteristic and your sample, which my example does right here. With my average number of textbooks, and then my sample, which is of 50 West Hill students. So just like how you have a characteristic that belongs to the sample, you also have a characteristic that belongs to the population, and that's what's called the parameter. So like I said, since it would be really hard to take a survey of all West Hill students, that's what the statistic is for. So these they both include a characteristic and a group of people, but this parameter is going to belong to your population. And the way that you can tell that if it's going to belong to your population or your sample is look at the first letter of each word. Parameter starts with P, and so does population. And then sample starts with S, but so does statistic. So yeah, that's how you know that they like go with each other. So yeah, a parameter is a characteristic. So I still want to figure out the average number of textbooks that all West Hill students have. And since that's what I'm trying to find, that is going to be my parameter. And this is population. So my population isn't 50 West Hill students, it's all West Hill students. So I'm going to make sure to include all of them in my parameter. So yeah, just notice how these are really similar, but then they're also really different. Because they're both trying to find the same type of characteristic. They're both finding average number of textbooks. But again, your parameter is trying to find a characteristic of your population, which is going to have to do with all people that you're interested in. But your statistic is only going to be dealing with your sample. And then in order to even find the average number of textbooks that all West Hill students have, I'm going to have to ask students, how many textbooks do you have? That way I can take their averages. And that's where your variable comes in. And your variable is the characteristic that you're interested in. Or it's like what you're asking each person for. So in this case, since I want to find out the average number of textbooks that all West Hill students have, the question that I'm going to be asking is, how many textbooks do you have? And the variable is going to be how many textbooks they have. And then it's called variable because your answers are always going to vary. Like, that's a keyword that I think of. So like the variable here is like how many textbooks each students have. There could be a student who uses 0, a student who uses 1, a student who uses 2. Notice how these answers are all varying. And then when eventually these 50 students are going to give me 50 numbers, and that's where your data comes in. And then your data is basically a list or a table or a graph of all your results. So eventually I'm going to get like 50 responses of how many textbooks that these students have. And then I can choose to sort them through a list, a table, or a graph. All that matters is that either way, I'm able to organize my information. So let's just say that I decide to just do a list. So then my data would be a list of all 50 students' responses. And then just a reminder, your population and your sample are only going to be about people. And then your parameter and your statistic, they're going to be a measure of people. And you're going to be able to differentiate them by looking for the keywords. So your parameter is just going to be a characteristic that belongs to your population. Usually it's like the average, but of the population. So keep an eye out for that word all in there. And then your statistic is still going to be a characteristic, but only of your sample. So it's not going to be of all people, it's only going to be of a much smaller group of people from your population. And then your variable is like basically what each person is going to answer you with. So in my case, for this example, it's how many textbooks a student has. And then your data is just going to be a list of all of your information. I'm going to be going over the levels of measurement, and the first one is going to be nominal. And nominal is level of measurement that's only categorical. And there is no order because it wouldn't make sense to order it. And then examples would be like colors. In addition to colors, you can also think of chips as one, or cars. So there really can't be an order for these, because it wouldn't make sense to say blue is ahead of red. Blue is more than red. And then the next one is going to be ordinal. And then this is type of data that can be categorical or qualitative or quantitative. And the difference between nominal and ordinal is that this one for sure has order in it. So try thinking of like metals. So although these are colors, they can be put in an order. Like bronze is third place, silver second, gold is first. But notice how colors can't have that same type of order just in general. And then after ordinal, you're going to have your interval. And then this is one that's quantitative. And then you can do math with your data. So you're able to like find differences. And then another thing that helps me identify interval is that 0 is not your starting point. And then an example of this would be temperature. So temperature, since it's numbers, it is quantitative, and then you can do math. You could check if yesterday's temperature was more than yesterday's temperature by doing the math and subtracting them from each other to see exactly what the difference was. And 0 is not your starting point. So temperature can actually be below 0 because you do get below freezing. So yes, it could be either below or above 0. And since it can be below 0, it would be categorized as interval. And then you have your ratio, which is the final level of measurement. And then ratio is also quantitative. And you can still do math with it. And then 0 is your starting point. So I would say that height or weight are good examples of this because you could see how 0 is a starting point. No one can be like -5 feet tall because height starts at 0. Same for weight. Weight also starts at 0. You can't be like -pounds. You could only be 0 or above. Either it has weight or it doesn't because it starts at 0.